In this video, we're going to be discussing chemical bonds, and we have a chemical bond chart to give us an idea of the different types of chemical bonds. And as you can see, there are three columns. The second column ends up splitting, but three columns. So there's three different ways that atoms can stick together or connect or bond. And they're called chemical bonds. And so we made a chemical bond chart. The first type of compound, and a compound is two or more different atoms stuck together. And the first type of chemical bond is going to be called, or chemical compound, is going to be called an ionic compound. And ionic compounds are made from ionic bonds. Not always do we call the compound name and the bond name the same. When we get to here, we will have a certain name for the compound and a certain name for the bond. Here later we'll have a video on molecular compounds formed from a covalent bond. The types of atoms that are involved in an ionic bond is you have a metal. One of the atoms is a metal atom, and the other atom is a non-metal atom. So as a reminder, I want to look at the periodic table and remind you of the structure of the periodic table. Here on the periodic table, we have a dividing line between the metals and the nonmetals. Now, along this dividing line, we have some semi-metals, but this dividing stair-step line really separates the metals from the nonmetals. So anything on this side of the periodic table, this side of the stair-step line, these are all metals. And anything to the right of the stair-step line, these are all non-metals. We know that metals, their preference is to lose electrons, and we know that non-metals have a preference of gaining electrons. So the only exception to this is hydrogen. And I like this periodic table because it separates out hydrogen. Hydrogen's really a non-metal. It belongs over on this side. But we have to leave them in column 1A because it has one outer electron, one valence electron. So on the left side of the periodic table, we have all the metals. And on the right side of the periodic table, we have all the non-metals. So when we are looking at two atoms coming together to connect, to stick together, to bond, one way that they can do that is if one atom is from this side where the metals are, and one atom is from this side where the non-metals are. The metal is going to lose its electron, and the non-metal is going to gain its electron. Now, one of the things I want to point out to you is that when the metal atom loses its electron, it turns into an ion. It turns in, because you're losing a negative electron, you turn into a positive ion. The nonmetal is gaining electrons, so it's going to turn into a negative ion, and that is why we call the compound an ionic compound and the bond an ionic bond. So both of those have their meanings based off of the atoms are turning into ions. So no longer is it a metal atom, it's a positive ion. No longer is it a non-metal atom, it's a negative ion. And so when they stick together, we call them an ionic compound, and the bond, the connection, is called an ionic bond. The electronegativity difference needs to be 2.1 or greater. And I want to expand on that concept of electronegativity difference. When we look at an electronegativity chart, and this is on the back side of your oxidation state chart, when we look at electronegativity chart, I want to remind you it is an attraction for electrons. Electronegativity is an attraction for electrons. So you can see over here, the nonmetals have a very high attraction for electrons versus the metals over here have a very low attraction. So if we put that dividing line in, the dividing stair-step line, you can see that it turns out the nonmetals over here have a high electronegativity. And over here, the metals have a low electronegativity. Because of the difference in electronegativity, you can think of it as a tug of war, where the nonmetals are very strong in attracting electrons. The metals are very weak in attracting electrons. Because of the difference in electronegativity, the nonmetal is so much stronger, it can take the metal's electrons away, the outer electrons. So because of the difference in strength of being 2.1 or greater, what happens is there is a transfer of electrons. Because of this difference in strength, where one is very strong and one is very weak, there is a transfer of electrons. Later, we will find out if the difference is not that big, if their strength is closer, then there is not a transfer of electrons. One of the atoms is not strong enough to take the other atom's electrons away. But here, because of the difference in strength, the non-metal atom takes the metal's electrons away. What we end up with at the very end is called an ionic crystal structure. An ionic crystal structure. This is a model of an ionic crystal structure. And what we would have is a metal atom losing electrons to a non-metal atom. So maybe this is the metal losing electrons to the non-metal. This becomes a positive ion. This becomes a negative ion because of the transfer of the electrons. But it does not happen in isolation. It does not happen with just a metal, one, and one non-metal. It happens in a repeating pattern. So you have a metal with a non-metal, another metal with a non-metal, another metal with a non-metal, and it repeats this pattern, making a crystal structure. All ionic compounds create an ionic crystal. They are all solid at room temperature. So in our everyday lives, you will always, every time you have an ionic crystal, a metal atom and a non-metal atom forming ions, you will always have a solid ionic crystal. When you look at these under a magnifying glass or a microscope, these substances, there will be cubes of crystal structures, and we call it an ionic crystal. The smallest unit that occurs in an ionic crystal structure is called a formula unit. The smallest unit is called a formula unit. What that means is when we get an ionic crystal, even though this pattern repeats itself over and over again, we're going to often refer to this smallest repeating unit. And that smallest repeating unit is a formula unit. The example that I would like to give is sodium, Na, and I'm going to draw Na with one valence electron. So when I look up Na, Na is on the left side of the periodic table. It's a metal. It's in column 1A, so I put one electron on the outside. The other one I'm going to pick is Cl. Cl is in column 7A, so it's got 7 electrons on the outside. And I'll follow the pattern of the Lewis dot structure. Because sodium's a metal, it wants to lose electrons. Because chlorine is a nonmetal, it wants to gain electron. It fits into this category. It's going to make an ionic crystal. If we looked up Na, it's got a value of 0.93. If we look up Cl, it's got a value of 3.16. It is 2.1 or greater. So what happens is the Na takes its electron and transfers a transfer of electrons over to Cl. Na is no longer an atom. It becomes a positive ion. Cl is no longer an atom. It becomes a negative. It's lost or gave away or transferred a negative electron. This gained a negative electron. So now this positive is attracted to this negative. Opposites attract. It took one Na to match the one Cl, so we end up with NaCl as the formula. The formula would be listed as NaCl. Now, in reality, it does not exist as one Na plus and one Cl minus. It's a repeating pattern of positive and negative, positive and negative, positive and negative ions. The smallest unit we call a formula unit. This one Na plus and Cl minus we would call a formula unit, and the whole structure, the whole three-dimensional structure is called an ionic crystal. There are three types of chemical bonds that we will end up discussing. This unit is going to be ionic compounds formed from ionic bonds, where you start with a metal atom and a non-metal atom that has an electronegativity difference of 2.1 or greater. The metal atom transfers its electrons to a non-metal atom. The entire structure is called an ionic crystal. The smallest unit we call a formula unit. And an example looks like Na losing an electron to Cl, forming an Na plus and a Cl minus with a formula of NaCl. I hope this helps in understanding ionic compounds.